about light travelling in straight lines, and the formation of shadows is more evidence to us that light does travel in straight lines. In this diagram we have a light bulb inside a black box, and there's a tiny little hole in front of it in which the light can pass through. In front of the light box we have a ping pong ball, and that's hanging from a string. And this is a screen. And we are going to describe how the shadow is formed on this screen as the light meets the ping pong ball. Well, what happens is rays of light leave the light bulb through the hole in the front surface, and some of the light rays will pass the ping pong ball above it or below it, but some of the rays will hit the ping pong ball and will be blocked. So those rays cannot pass through the ping pong ball. So how is the shadow formed then? Well, where the light is stopped, we have the black shadow. But the edges of the shadow are formed by the rays that do pass. So coming from this gap, we can draw a line from the gap across the top surface of the ping pong ball, and that forms the top surface of the shadow. So the light ray travels out and passes just the very top edge of the ping pong ball, and this is what produces the top edge of the shadow. The same happens at the bottom of the ping pong ball. The light travels from the very edge of the box to the bottom, and the resultant shadow, it has the same shape as the object. The ping pong ball was spherical and we have a round shadow, and it has distinct or sharp edges, so there's a very clear outline. This shadow is called an umbra, and this complete shadow, called the umbra, is formed when we have a point source. And a point source is a source whereby we can consider all the rays of light come from one single point, as shown by this slit. So all the rays come from one single point, and we get this sharp, clearly defined shadow. Now, if we have a slightly different source called an extended source, all the rays of light do not come from one point. In this case, the slit is bigger. So some rays could come from the top of the slit and some could come from the bottom of the slit. If we look at the bottom of the slit first, some of these rays coming out, they come in all directions, will pass the top of the ping pong ball and meet the screen. Some of them will pass the bottom of the ping pong ball and meet the screen. All the rays in between here are all stopped by the ping pong ball. Then again, there are lots of rays coming out all through this gap, but if we look at the very top of the diagram, we can see that some of the rays passing the bottom of the ping pong ball, and some of the rays will pass the top of the ping pong ball. What we see when we have an extended source is that there's a range of rays of light that come out from the extended source, from the bigger slit, and whenever we look at the shadow, we have a fuzzy, lighter outline and a complete shadow in the centre. And in this fuzzy outline, at the top of the fuzzy outline, some of the rays from the bottom of the slit are getting passed, and at the bottom, some of the rays from the top of the slit are getting passed. In the dark centre, all of the rays have been stopped by the ping pong ball, And this fuzzy outline is where some light's getting through from some positions in the extended source and some isn't, or some aren't. We call this complete shadow at the centre the umbra. And the fuzzy outline has a different name. It's called the penumbra. So we have a more complex shadow formed when we have the extended source. We still have the complete or umbra shadow in the centre, which is completely dark, and then we have this fuzzier, grey, lighter shadow, which is a bit more indistinct around the outside, and it's called the penumbra. Now, to revise what we have learned, the different terms that we have learned. Transparent. Transparent means lets light pass through. Opaque is a type of material that does not let light pass through. Translucent then, it's like a halfway between the transparent and the opaque, allows only part of the light to pass through. When we say that an object absorbs light, that means it soaks up the light. If it emits light, it's a light source which gives out light. And whenever we say that an object reflects light, what we mean is the light bounces off the surface of the object. These terms, particularly terms 1, 2, 3, 5 and 6, are important when you're describing light. And just to have a look at some other statements. Are these statements true or false? The moon is a light source. Let's remind ourselves, a light source means that it gives out light. And although the moon appears to be bright, this statement is actually false. The moon reflects light from the sun to our eyes. So we only see the moon because it is reflecting light produced by the sun. It does not actually produce its own light. That then answers question 2. The sun is a light source. Well, this is true. Light sometimes travels in curved lines. Never. It always travels in straight lines. So that statement is false. Luminous objects radiate light, energy as light. This is true. Light is a form of energy. And luminous means that it gives out light. And sound travels faster than light. This is false. It's completely the other way round. So, to summarise the main points of this video cast, light carries energy and it travels in straight lines as a wave. That's important as well. It travels in straight lines at very high speed, 300 million metres per second, and it travels as a wave. The amount of energy that it carries depends on the brightness and the colour of the light. And one other point that we will learn about in the third video cast is about blue light carries more energy than red light. And we will learn more about this and discuss this further in video cast 3. This concludes the introduction to light and the properties of light. Move on now, please, to the video cast on reflection.